All right, guys. Hey, I'm not going to do a full-blown lesson or video, but I thought it would be helpful after the presentation you watched on volume to just go ahead and, even though I only assigned 3 questions, I want to go ahead and just kind of do one of them for you, one more example to show you. Again, I know this is tricky, so let me just kind of talk through number 13. Okay, so if you watched it, you're trying this, you're having trouble. Let me show you all I expect you to do, okay? We need the volume of a sphere, radius of 5. This is problem number 13. Remember, it all revolves, no pun intended. It's supposed to be a 5, there we go. It all revolves around a circle in our case, rotating around the x-axis so that you actually get this effect of this 3-dimensional object, which is going to be a sphere. It's the same effect of taking off your ring or a quarter and spinning it on the table. What does that look like as it spins and rotates? A sphere. Okay? The key is you're slicing this shape up into cylinders. Okay? Like so. A whole bunch of cylinders. It looks like mine happen to be right end points. They can be midpoints, they can be left end points. I actually forget what number 13 asks for, but that doesn't matter right now, okay? But the point is you're slicing this shape up into different parts, okay? Now, the key here, if this is a sideways cylinder right here, we know that the volume of a cylinder, actually, let me backtrack and then I'll get to that here. Let me start with this. Whatever this shape here is, you need that equation. So we talked in my presentation that the equation for a circle, this case with a radius of 5, not 7 or 4 or whatever it was in the video, with a radius of 5 would be the square root of 25 minus x squared. That's the beginning of the problem, okay? So now back to what I was saying. This is all about volume. How do you find the volume of a cylinder? Of a sideways cylinder? Well, volume of a cylinder is pi r squared times height. Okay? Continuing on, what is the radius of the cylinder? And this equates back to what we've been doing really this whole time in class. I want this length here, or this length here, or this length here, or that length there. What is that? That would be, by the way, the radius of our cylinder. That's the curve itself. So even though we're in 3 dimensions now instead of just 2, this distance right here and here and here and here is still the curve itself. So when we go pi r squared times height to get a volume of a cylinder, it's pi times radical 25 minus x squared times height. Now, what's the height? Well, the height is this dimension, this dimension. It's the spacing of each of these. Remember, they're sideways cylinders. Well, that's just going to be how many slices you make. So if you make 10 slices, then each one is 1. If you make 20 slices, each one would be a half. Well, the good news for you in these 3D problems, you don't have to worry about that part. Just put change in x, okay? Let's simplify this. We end up with squaring a square root, so that's going to end up being pi times 25 minus x squared times change in x. And actually, that's all the further you have to go. As I tried to explain, and I may not have done a good job at this, I only want your setup because to finish that problem, you need the calculator program, which you don't have because I didn't give it to you. I wasn't in school to be able to transfer that. So we're going to have to make do without it for now. That's all I would expect. Let me say one more thing. All the problems are not spheres. I think another homework question is a paraboloid. So think about the difference. You're still finding volume of a cylinder in every one of these because we're always going to slice it into cylinders. But the difference, if it's a paraboloid, is that that's your shape not a half circle. So think about what is the equation of this instead of radical 25 minus x squared? It's the square root of x, okay? So that'll really help you, I think, but just wanted to point that out. Give it your best shot. Have a good one, guys. I'll talk to you later.